So why does the deep convection process only take place in these specific regions? And the key reason is that you have the right preconditioning. Preconditioning, it's shown here in these three phases of open ocean convection, is a mechanism that already provides a relatively weakly stratified water column in these areas. So it's not that hard to create a deep convection. So the static stability of the water column is already relatively low. Okay, and this preconditioning is provided by the wind forcing actually in that area. Okay, that already creates some upwelling of, you can see here the upward bending of the isopiculas. Okay? It's the preconditioning mechanism. On the other hand, you also need the exposure to cold air outbreaks. These are events of very, very cold air masses and strong winds, creating a large heat loss of the surface, a strong or rapid cooling event of the surface layers. And this is what increases the density and kicks off convection, and this is called violent mixing here. Okay? And then what the mixed layer deepening that you get over a winter depends on the number of such cold air outbreaks. How many events do you get? Okay, do you get them more over the Labrador Sea, or do you get them more over the Greenland Sea? The last phase then is the spreading phase, the spreading of it. And the spreading phase is complicated due to the fact that the Earth is rotating. So instead of getting an easy, the dense water does not just disappear, it creates something we call eddies, which are indicated here. And it creates also some, it's a mechanism called geostrophic adjustment, but it also has a memory effect. So some of the disturbances of the density field that are created over the winter season also remain and might influence what happens in the next winter. So there are three phases of open ocean convection called preconditioning, violent mixing, and spreading. And this all has been proposed by Peter Kilworth a while ago.